Lesson 1-3 has two topics in it, distance and midpoints. So in this video, we're going to look at how to find the distance between 2 points. So I'm calling this 1-3A. How can you find the distance between 2 points without a ruler? Whenever you connect 2 points on a number line or on a plane, you have graphed a line segment. Distance on a number line is determined by counting the units between the 2 points. On a coordinate plane, you can use our friend the Pythagorean theorem to find the distance between the 2 points. In the figure, to find the distance from A to B, we're going to do A squared plus B squared equals C squared. They didn't finish the problem, but let's look at it real quickly, just reviewing Pythagorean theorem. So it would be 25 plus 36 equals C squared, which is 61. But we're going to know C, so we're going to take the square root of both sides. So that means C equals the square root of 61, which is approximately, using the calculator, 7.81, rounding to the nearest hundredth. Now it's a step easier if they give us 2 points on a number line, because we're just going to find the difference to find the distance between them. They went ahead and put absolute value bars around there, which shows that it doesn't matter which one's first. We're getting the difference of them. So general practice, I think people end up putting the biggest number first, and then you don't have to worry about absolute value. Unless, of course, both numbers are negative. There's always that. Okay, so if we find the absolute value of -6 minus -3, minus a negative, remember, it's the same as a plus. And so -6 plus 3 is going to be -3, and so that is 3. Or, using your awesome counting abilities, you could have counted 1, 2, 3 spaces between them. Finding the distance on the coordinate plane kind of uses the distance we did on the number line, because we've got the difference happening here. So since this one was already graphed, we could just count, hey, this is 6 units. But if we didn't have it graphed, so if we hadn't graphed and we're just looking at ordered pairs, the difference in the x's would be 7 minus 1, which was 6. And the difference in the y's would be 6, happens to be minus 1 there also, which is where we got our 6 squared plus 5 squared. Okay, now this looks a little bit different than the Pythagorean theorem, because instead of the d being squared, they went ahead and took the square root of both sides of the equation. So it's very familiar to us as the Pythagorean theorem, just as a d instead of a c. Okay, we've done that same problem twice now. Let's look at a new one. They ask us to find the distance between -4 and 1 and 3, -1. You could use graph paper, plot the points, and do Pythagorean theorem. So remember, -4 to the left, 1 up, 3 to the right, 1 down, and then we've got the vertical rise there is 2 units, and the horizontal, I'm actually going to subtract. That's -4, that's +3. So -4 to 0 is 4. Okay, so that's going to be 4 plus 3 is 7, and we said that was 2. So we're looking for the hypotenuse, the side opposite the right angle. So 2 squared plus 7 squared equals c squared. 4 plus 49. So we have c squared equals 53. So that means c is going to have to be the square root of 53. So using a calculator, the square root of 53 is approximately 7.28 if we round to the nearest hundredth. Okay, distance formula, we need the difference in the x's. Now, some of you may not want to take graph paper and plot points every time, so we could just use the distance formula. Now, if you like, we could label the points x sub 1, y sub 1, x sub 2, y sub 2, and then we can plug them into the formula. So we're going to have d equals We want the difference in the x's, so it's going to be 3 minus -4. I'm lazy, I'm just going to put a plus 4. Squared plus the difference in the y's. So y sub 2 is -1, y sub 1 is 1. Squared, and then we're going to have to take the square root of that whole business. So we've got 3 plus 4 is 7. And -1 minus 1 is -2. So now this looks very familiar. We have 49 plus 4, which happens to be the same as 4 plus 49 by the commutative property of addition. So D equals, and once again, the square root of 53, which is once again approximately 7.28. So you can choose your method.